Welcome to Daily Papers.
The podcast where we dive into fascinating new research papers.
Today we're talking about artificial intelligence, art, and a little bit of espionage. We're looking at the world of generative AI leaderboards.
Right, these are the public scoreboards that tell us which AI models are the best. If you've ever used a tool like Midjourney or DALL-E to create an image from a text prompt, you've used a text-to-image model. And there are dozens of them, all competing to be the smartest, the most creative, or the most realistic.
To figure out who's best, some platforms use a system that's basically an AI beauty pageant. It's called a voting-based leaderboard. You're shown two images generated from the exact same prompt, but created by two different anonymous AI models. Your job is simple. Pick the one you like more.
It sounds like a fair way to do it. The models are anonymous, so you can't be biased towards a big name. You're just judging the art. The model that gets the most votes wins and climbs up the rankings.
In theory, yes, but a new paper titled Text-to-Image Models Leave Identifiable Signatures suggests this anonymity is basically a myth, and that opens the door for some serious cheating.
Okay, you've got my attention. How can you cheat if you don't know which image is which?
Well, that's the whole trick. To cheat, you first need to figure out which image your model made so you can tell all your friends or your army of bots to vote for it. This process of unmasking the anonymous model is called de-anonymization.
And this paper is saying that de-anonymization for image-generating AIs is not just possible, but actually easy?
Shockingly easy. The researchers found that every text-to-image model has a distinct, identifiable signature. Think of it like a famous painter. You can look at a painting of a starry night and just know it's a Van Gogh because of the thick brushstrokes and swirling colors. Even if he and Monet painted the exact same scene, their styles would be completely different.
So these AI models have their own unique artistic styles, their own digital brushstrokes.
Exactly. The paper shows this beautifully. They took the same prompt, something like an impressionistic painting of a bustling city street in the rain, and gave it to several different models. Then they had each model create 5 different versions.
And what did they find?
They found that all 5 images from, say, Midjourney looked very similar to each other in terms of style, color palette, and composition. But they looked completely different from the 5 images generated by Stable Diffusion or the 5 from GPT Image. Each model has a consistent and unique visual fingerprint.
Okay, so our eyes can see the difference. But how does a computer see it? How did the researchers turn this observation into an actual method for de-anonymizing the models?
This is the really clever part. They used a tool called CLIP to analyze the images. You can think of CLIP as a kind of universal art translator. It looks at an image and converts its essence, its content and style, into a string of numbers, which is called an embedding.
An embedding. That sounds technical.
Let's simplify. Imagine a giant library where books aren't organized alphabetically, but by their content and writing style. All the swashbuckling pirate adventures would be in one corner. All the minimalist poetry would be in another. Within the pirate section, you'd find little clusters for different authors. The embedding is like the book's specific coordinate in that library.
So images that are similar end up close together in this giant digital library.
Precisely. The researchers took over 150,000 images generated by 19 different AI models and plotted them all in this embedding space, and they found clear, distinct clusters. There was a Midjourney cluster, a DALL-E 3 cluster, a Stable Diffusion cluster, and so on. They were all in their own little neighborhoods.
I think I see where this is going. The attack is just taking the anonymous image from the leaderboard, plotting it in this library, and seeing which neighborhood it lands in.
That's it. It's that simple. They calculate the center of each model's cluster, the centroid, and see which center the mystery image is closest to. The closest cluster is their prediction for who made the image.
And did it work?
It worked incredibly well. Their method could identify the correct model on the very first guess with 87% accuracy.
87%?
What would a random guess be if there are 19 models?
A random guess would be right about 5% of the time. So going from 5% to 87% is a massive leap. And it gets better. They were 95% sure that the correct model would be in their top 3 guesses. It's like having a cheat sheet for the AI beauty pageant.
So this whole idea of an unbiased, anonymous competition is basically broken.
It seems that way for text-to-image models. The very thing that makes them special and gives them a competitive edge, their unique visual style, is also what makes them vulnerable. It's a paradox. Their signature is their weakness.
What are the real-world consequences of this? So what if someone games a leaderboard?
It's a bigger deal than it sounds. These leaderboards aren't just for fun. They guide research directions. They influence which models get funding and which ones get integrated into the apps and services we use every day. If the rankings can be easily manipulated, then we might end up promoting worse models and stifling innovation. It erodes trust in the whole system.
The paper also mentioned that some prompts are better than others at revealing these signatures, right?
Yes, and that's another scary part of this. Some prompts are what they call perfectly distinguishable. A simple prompt like a photo of a cat might generate similar-looking images across all models, but a more complex artistic prompt can act like a special key that forces a model to reveal its true identity.
And an attacker who can submit their own prompts to the leaderboard could use these special keys to de-anonymize models with near-perfect accuracy.
That's what the researchers found. If you can control the prompt, the game is over. You can identify the models with near-perfect certainty.
So what's the solution? Do we just get rid of leaderboards?
The paper suggests we need to build more robust defenses. Maybe the leaderboards could limit the number of times an image from the same prompt is shown, or maybe they could use AI to analyze voting patterns to look for suspicious behavior, like one model suddenly getting a flood of votes.
It sounds like a new kind of cat and mouse game. As AI models get better, so do the methods to attack the systems that rank them.
It's a fundamental tension. We want our AI models to have unique, creative, and recognizable styles. But this research shows that this very uniqueness can be exploited. It's a fascinating look at the hidden security challenges that come with the rapid progress in AI.
A great reminder that even in the world of advanced technology, making things fair and secure is a very human problem.
Thanks for listening to Daily Papers.